earthquakes and flooding and their cascading effects. So sometimes an earthquake will induce a landslide, or a flood will induce a landslide, so that would be a cascading effect. And this final conference is to disseminate the key aspects of the research. And they are stress testing, hazard assessment, and structural vulnerability. So we want to demonstrate the validity of the methodologies that we have developed and show you a little bit about the tools we have developed. We have a couple of case studies, examples, and we have some decision support software tool. So we've also looked at some of the similar European Union projects. So the European Commission brought us all to Brussels one day and said, you need to talk to each other. So we've made an effort to stay in touch with similar research projects, other research projects on similar topics. So we will have representatives from 2 of those projects here today. So we're funded by the European Union's 7th Framework Programme, but as Miguel has said, this is quite similar to the Horizons 2020 programme. So that's because we're 3 years old. Horizons hadn't started when we started this. It's the Environment Work Programme, including climate change, of course. And this topic, the brief we were given, was to develop stress tests for critical infrastructure against natural hazards. So we've been going for just about 3 years, and our budget has been 2.8 million euro. So some background, we want to improve the preparedness and the resilience, or reduce the vulnerability of society to these extreme events. So natural hazards appear to be increasing, probably are increasing. Land is being used more intensively. The European Union is expanding, mostly eastwards. Our infrastructure is getting older. We built a lot in Europe after the Second World War, and we're building much less now. So on average, our structures are getting older. Of course, climate change is having an effect, but human activity is also having an effect. So we want to protect these structures, and we want to be able to better plan our preparedness and improve our resilience with a focus on the pan-European networks. So taking 2014 as an example, there were 324 disasters around the world. 141 million people were affected. It's an enormous impact, and 8,000 people died. The economic damage of almost 100 billion American dollars. So these disasters, we cannot prevent them, we should try to mitigate them. So taking some examples, the Izmit earthquake in Turkey. There was a railway running parallel to the fault line, and this was seriously disrupted. Roads were damaged by landslides. 60 kilometers of the trans-European network were disrupted by a viaduct collapse. 17,000 people died. 500,000 people lost their homes, and the reconstruction costs were estimated at about 15 billion euro. So very serious impacts. We've also had floods. There were Central European floods in 2002. 250 roads and 256 bridges were damaged in Germany and the Czech Republic. We had a similar problem in the UK in 2013 and 14, damage of about €1 billion. So we need to be able to assess resilience so that we can prioritize spending. We believe that about 96% of current spending is on the response to these disasters, and only about 4% on prevention and preparedness. This is crazy. We can save a lot of money by spending more money on prevention and preparedness. If we were to improve flood defences to cater for the 1 in 100 year flood, it would cost about €1.75 billion. That's a lot of money, but it would save us about €7 billion. So it's a no-brainer, as the Americans say. The challenges are significant. Traffic is growing. So around Europe, over the last 20 years, not counting the recession, there's been a very steady growth in the ton kilometres of freight traffic, 1.5% to 2% per year. It doesn't sound like much, but when it accumulates over many years, it doubles every 20 or 30 years. This is a huge challenge. And as I say, the infrastructure is aging. 30% of our railway bridges are more than 100 years old now. And of course, we're all under budget pressures. Our budgets are being challenged all the time. So the InfraRisk has focused on developing a stress testing methodology. So Miguel already mentioned this, so assessing the sensitivity to damage. We're looking at these low probability, high consequence natural hazard events. People sometimes call them the black swan events, the rare events with high consequences. And we're looking at earthquakes, floods, and landslides. So some of the other projects that I mentioned are looking at other types of threat, but we're focusing on the natural ones. We're focusing on the 10T network, the main strategic European networks. And our goal is to quantify the risks. So, and we assess the damage in terms of physical damage, transport delays, and economic loss. So we try to take a wide view. So some of our outputs, we're developing a harmonized multi-risk assessment framework, so a way in which you can assess the risk. We're specifically developing a decision support tool, a software tool, so we'll have a user-friendly environment to allow people to use this. And we're developing some very nice training modules for infrastructure managers. This is our partnership. So we have 11 partners from around Europe, mostly from the western side of Europe. We have 5 SME partners, small and medium enterprise SME. So Rona Donovan is our company. We have about 100 staff. We're consulting engineers, consulting civil engineers. GDG is a geotechnical specialist consulting firm in Ireland. PSCT, specialists in hydrology and risk calculation in the Netherlands. PSJ are security specialists in the Netherlands. And Ritchie Consulting calculates risk and is based in Sweden. We have some very good research institutes and universities. ETH Zurich from Switzerland, top-class university, as is University College London. CSIC, you probably know, the Spanish Research Institute Council. University of Southampton, we're working with a spin-out institute of the University of Southampton. And SINTEF are a very large research institute in Norway. And of course, we have an industrial partner in Dragados. This is the stress test framework. So stress testing, the banks have been doing it. It's basically looking at sensitivity to a disruption, sensitivity in our case to a threat. And we're looking at these kinds of hazards, so earthquakes and floods. So we start with maps. What's the flood risk or the earthquake risk in different parts of Europe? And we're looking at bridges, tunnels, landslides, and we're looking at road and rail. And most of the results are in this form of these kinds of graphs. So this graph on the x-axis, there's a particle ground acceleration, so that's your threat, in this case an earthquake. And the y-axis, it's a probability of being damaged. So we can tell by looking at these graphs how vulnerable we are. So of course, if there's a major earthquake, you expect damage. But if there's a minor earthquake, you expect a lot less damage. And a small investment can often be very, very useful in this case. We have included traffic models so that when there is something like an earthquake or a flood, we see how does the traffic divert. Is it a big deal? If there's another road running parallel, you can divert the traffic. It's not a big problem. Similarly, in a railway line. But if there's a bottleneck, then there is a problem. So we need these traffic models to be part of it. And we have 2 case studies. So one is in the Bologna area in Italy. This is an earthquake study, and the other is in Croatia, on the railway line in Croatia. So you'll hear more about them during the day. This is the overview of the decision support tool. So this is a software interface to our methodologies. Looks very nice. We have training course, so we're still finishing off some of these. So we have our first training tools for infrastructure managers are now available. These are some of the other projects that are in similar areas. So RAIN is coordinated by Trinity College Dublin in Ireland. It's about risk analysis of infrastructure networks in response to extreme weather. So they're looking at weather-induced events. So they're not looking at earthquakes, for example. There are small differences between these projects. INTACT is led by TNO in the Netherlands, looking at the impact of extreme weather on critical infrastructure. And STRESSED is led by ETH Zurich, and it's looking at a harmonized approach to stress tests for critical infrastructures, again for natural hazards. So this is our program for the day. And thank you very much.